Good morning, my dear students. Today we are going to talk about the classification of carbohydrates. Okay? The classification of carbohydrates, now we are going to classify the carbohydrates into two major groups, simple sugar and the complex sugar. What is the difference between simple sugar and complex sugar? First of all, you have to know that each polymer consists of monomer inside. So the simple sugar is the carbohydrates that its polymer consists of only one monomer inside or two monomers joined together. So again, the simple sugar is a type of carbohydrate where the polymer consists of only one monomer inside or two monomers joined together. If I want to explain the complex sugar by the same meaning or the same way, so the complex sugar is a type of carbohydrate where the polymer consists of group of monomers joined together, means more than two monomers joined together. We call this type of carbohydrate complex sugar. So we have simple sugar and complex sugar. If the polymer consists of only one monomer inside or two monomers joined together, so we call this type of sugar simple sugar. If the carbohydrates consist of, or the polymer consists of greater than two monomers joined together, so we call this type of carbohydrate complex sugar. Also we have properties of simple sugar. The simple sugar or the simple sugar soluble in water or dissolve in water, or the simple sugar have low molecular weight, as the polymer here consists of only one monomer or two monomers joined together, so the simple sugar, all the simple sugars have low molecular weight. Number three, all the simple sugar, they have sweet taste. They have sweet taste. If we want to compare the characters or the features of the simple sugar and the characters of the complex sugar, you have to understand that all the simple sugar dissolve in water, but the complex sugar, they don't dissolve in water. All the simple sugar have low molecular weight because the polymer here consists of only one monomer or two monomers joined together. While the complex sugar, the polymer here consists of greater than or more than two monomers joined together, so they have high molecular weight. Number three, all the simple sugar have sweet taste, but the complex sugar, they don't have any taste. Only another, we have one point I have to explain in the simple sugar. The polymer that consists of only one monomer inside, we call this type of simple sugar monosaccharides, as the word mono means one, and saccharides in Latin means sugar. So the sugar that consists of only one monomer inside, we call this type of sugar monosaccharides. And the sugar that consists of, or the polymer consists of two monomers joined together, we call this type of sugar disaccharides. Okay? Monosaccharides and disaccharides under the simple sugar. So the simple sugar includes monosaccharides and disaccharides. What are the monosaccharides? They are carbohydrates from simple sugar. Its polymer consists of just one monomer inside. What about the disaccharides? They are carbohydrates from simple sugar. Their polymers consist of two monomers inside. Next step, we are going to talk about the monosaccharides in details. What are again the monosaccharides? They are carbohydrates from simple sugar. Their polymers consist of one monomer inside. Okay? We have another point which is very important in the monosaccharides. All the monosaccharides contain carbon atoms ranged from 3 to 6. It means if we have, for example, carbohydrate like glucose, which is one of the carbohydrates, its chemical formula C6H12O6. If you look at this formula, you will find that this carbohydrate contains carbon, hydrogen, and oxygen with ratio 1 to 2 to 1. If you look at the number of carbon atoms, you will find that the number of carbon atoms equal 6. So glucose is one of the monosaccharides. So all monosaccharides contain carbon atoms range from 3 to 6. Another example of monosaccharides, ribose, which is one of the carbohydrates. The chemical formula of ribose is C5H10O5. It means it contains carbon, hydrogen, oxygen with ratio 1 to 2 to 1. And the number of carbon atoms here equal 5. So it means it's one of the monosaccharides. So how can I know the monosaccharides? They contain carbon, hydrogen, oxygen with ratio 1 to 2 to 1, and also the number of carbon atoms range from 3 to 6. These examples are the examples of monosaccharides. We have here the glucose, we have here fructose, and we have here galactose. There are 3 examples of monosaccharides. Each one of them, the chemical structure or the chemical formula of each one of them, C6H12O6. It means that they contain carbon, hydrogen, and oxygen with ratio 1 to 2 to 1 respectively, and also they contain carbon atom, 6 carbon atoms. So the chemical structure, the chemical formula of glucose, fructose, and galactose, C6H12O6. But they differ from each other in the structure, as we see. Okay? The figure, or this circle, or this figure, or this hexagonal shape, it means this sugar consists of only one monomer. So if we put 2 of the hexagonal shapes together, or 2 circles together, it means we refers to disaccharide. So the monosaccharides, we can put just 1 circle for the monosaccharides, 2 circles joined together for the disaccharides. More than 2, so we are going to talk about the complex sugar. This slide talk about different examples of monosaccharides. I said that monosaccharides contain carbon atoms ratio, or the ratio of carbon atoms from 3 to 6. So the first one, C3H6O3, which is one of the monosaccharides according to the number of carbon atoms. We have C4H8O4. This is also monosaccharide because number of carbon atoms equal 4. C5H10O5 or C6H12O6. We call this one triose sugar. Triose, it means contains 3 carbon atoms. Tetrose, because tetra in Latin it means 4, so it contains 4 carbon atoms. Pentose sugar, because penta in Latin means 5, so pentose sugar, it means the sugar that contains 5 carbon atoms. Hexose sugar, it means this type of sugar contains 6 carbon atoms. And all of them are considered monosaccharides because the number of carbon atoms range from 3 to 6. The first example of monosaccharides is glucose, which is the grape's sugar. And this is the structure of glucose. It's a structure C6H12O6. This is another photo for the structure of glucose. Look at this figure. Each point of connection is considered a carbon atom. So we have here the first carbon atom, second one, third one, fourth one, and fifth, sixth. So it means that this type of carbohydrate contains 6 carbon atoms. So it is considered from monosaccharides. And the structure of this glucose is C6H12O6. The second example of monosaccharide is fructose or fruits sugar, except the grapes, because the grapes sugar is glucose. So the second example of monosaccharide is fructose. Fructose is the grapes, fruits sugar, okay? This is the structure of fructose. We can write the structure as this type, or we can write the structure like this. Almost both of them, the chemical structure of fructose, C6H12O6. Third one, or third example of monosaccharide is ribose. Ribose is one of the monosaccharides. Its chemical formula, C5H10O5. So it's one of the examples of monosaccharides. So the ribose is a 5-carbon sugar. It's a pentose sugar. It means it contains 5 carbon atoms. And this is the structure of ribose, which is one of the monosaccharides. Example number 4 of the monosaccharides is galactose. Its chemical formula is C6H12O6. So also galactose is one of the monosaccharides. As we said that the monosaccharides contain carbon atoms ranges from 3 to 6. Now we are going to talk about the disaccharides. We said before that the disaccharides are examples of simple sugar. They are carbohydrates from simple sugar. The polymer here consists of 2 monomers bound together. So we can say that disaccharides are carbohydrates from simple sugar. Their polymers consists of 2 monomers joined together. Or we can say that the disaccharides consist of 2 monosaccharides joined together. Okay? The first example of disaccharide is sacrose. Sacrose is the sugar that is found in the sugar cane. It consists of 2 monosaccharides joined together. So what are these 2 monosaccharides? Glucose with fructose. If glucose molecule bound with fructose molecule, it gives, or they give, sacrose, which is one of the disaccharides. So the disaccharides, or the first example of disaccharides, is the sacrose. It consists of glucose molecule bound with fructose. Okay, and this structure shows the structure of sacrose. Glucose molecule bound with fructose molecule. Okay. Question or point number 2, or example number 2 in the disaccharides is the sacrose. Is lactose. Lactose is the milk sugar, or the sugar that is found inside the milk. It is also an example of disaccharides. It consists of 2 monosaccharides bound together. What are these 2 monosaccharides? Glucose with galactose. So if we put glucose molecule with galactose molecule, they give lactose molecule, or the sugar that is found in the milk. So this is one of the disaccharides. The last example of disaccharide here is maltose, or malt sugar, the sugar that's found in the barley or malt. It consists of also 2 monosaccharides joined together. What are these 2 monosaccharides? Glucose plus another molecule of glucose. So there is very important point here if I want to calculate the chemical formula of one of the disaccharides. If you want to calculate the chemical formula of the disaccharide, you have to know that the bond that formed between 2 monosaccharides is called glycosidic bond. This bond, or during the formation of this bond, there is only 1 water molecule released outside. So it means if I want to calculate the chemical formula of this disaccharide, you know that the glucose molecule is C6H12O6. And the glucose molecule, the next one, is C6H12O6. It means both of them equals C12H24O12. But you have to know that we have only 1 water molecule released from this bond. So from this chemical formula, you have to release 1 water molecule. So the chemical formula becomes C12H22O11. So you have to understand well that for each glycosidic bond formed between 2 monosaccharides, there is a water molecule released. So if I want to calculate the chemical formula of the disaccharide, you have to put the structure of this monosaccharide with the structure of this monosaccharide, then release 1 water molecule. Okay? So we have here glucose and another glucose, each one of them C6H12O6. So the total number, or the total chemical formula, C12H24O12, then release 1 water molecule, so the formula becomes C12H22O11. This figure shows how 2 monosaccharides join together to form the disaccharide. This figure is the glucose. For example, just 1 ring. This ring in purple is the fructose. This ring in green is the galactose. So we have 3 examples of disaccharides. The first one, the maltose. The maltose is the malt sugar. It consists of just one glucose molecule with another glucose molecule. So we have to put 2 blue with each other. The second example of disaccharide is the sacrose. It consists of glucose molecule plus fructose. So glucose plus fructose means the blue ring with the purple one. The third example of disaccharide is lactose. It is the sugar that is found inside the milk. It consists of glucose plus galactose. So we have ring of glucose plus the green ring of galactose. This structure or this figure shows how can the monosaccharides join together to form the disaccharide. So we have here monosaccharide. Here we have OH group, or we call this group hydroxyl group. And we have another OH group here. During the formation of disaccharide, the 2 monosaccharides link together to form glycosidic bond. And we have 1 water molecule released. So we have OH here and H from this group. So this is the water molecule released. And the O between them link between the 2 monosaccharides to form the disaccharide through or by glycosidic bond. These examples are examples of mono and disaccharides. So we have here, for example, glucose. Its chemical formula C6H12O6. We have fructose, also the chemical formula C6H12O6. We have another examples of monosaccharides, but take care that all monosaccharides, the number of carbon atoms range from 3 to 6. It means if the carbon atoms equal 3 or 4 or 5 or 6, so we talk about the monosaccharides. And take care that the ratio between the atoms 1 to 2 to 1 respectively between carbon, hydrogen, and oxygen. If we talk about the disaccharides, we have 3 examples here: sacrose, lactose, and maltose. The chemical formula of each one of them, C12H22O11. It means we don't follow the rule CH2O, because during the formation of disaccharides, each 2 monosaccharides join together, there is 1 water molecule released. So the formula becomes C12H22O11. The last type of sugar or the carbohydrates are the complex sugar. The complex sugar are carbohydrates where their polymer consists of group of monomers joined together. So what are the complex sugar? They are carbohydrates which consist of group of monomers or monosaccharides joined together. We have here 3 examples: cellulose, starch, and the glycogen. And the properties of the complex sugar, as we said before, differ from or the opposite of the properties of the simple sugar. Thank you.